Guys, good morning. These are the set of problems on mixtures and allegations. Straight away, we'll see the problems, guys. So just take a pause for 1 minute and try the question, and then continue with the solution. Let's see our first question. Two vessels contain spirit and water mixed respectively in the ratio of 1 is to 3 and 3 is to 5. If equal quantities were mixed, what is the ratio of spirit and water in the new mixture? That's it. So simple, guys. Spirit and water ratio is given. There are two vessels. In the first vessel, spirit and water is 1 is to 3 ratio. In the second vessel, it is 3 is to 5 ratio. Equal quantities were mixed. So in sense, if from first vessel, if I have taken 4 liters, in the second vessel also I have taken 4 liters and I have mixed it in that ratio. So in the resultant mixture, he is asking what is the ratio of spirit and water. So how to continue the problem is, instead of taking some random quantity, what I will do is I will see the total parts of first vessel, total parts of first vessel 1 is to 3, which is on the second vessel is 3 is to 5. So total parts of first vessel is 4. Let us assume it is 4 liters. It is of 8 liters. So what I will do is I'll make the first part is also 8 liters. How the reason is 8 second vessel 8 liters. 8 is a multiple of 4. So how I'll manipulate the ratio is I'll multiply the first ratio with 2, and the second ratio I'm going to take multiply with only 1 itself. So that means total parts will be 4 into 2 8, and this is 8 into 1 is 8. So that's how I made it into 1 is to 3 is multiplied with 2. I'll be getting resultant thing is 2 is to 6, and this is 3 is to 5. The ratio remains same. So I hope now this is a total part. First vessel is 8 liters and this is also 8 liters. So that means 8 liters and 8 liters if I mix. In the first vessel of 8 liters, 2 liters is of spirit and 6 liters is of water. And the second vessel 8 liters is of 3 liters of spirit and 5 liters of water. So that's how we have mixed them. So then what happens? The spirit power, the quantity of spirit will be 2 plus 3 5 in the resultant mixture. 6 plus 5 11 is the water parts of water in resultant mixture. So that's how I got spirit to water ratio in the resultant mixture. So this is what my answer, option C. Let's go and see our second problem. So this is given, guys. The problem is also similar to our first problem, but what happens here is it is given two vessels contain spirit and water mixed respectively in the ratio of 1 is to 3 and 3 is to 5. Find the ratio in which these are to be mixed to get a new mixture in which the ratio of spirit to water is 1 is to 2. So initial ratios were given as 1 is to 3, 3 is to 5, and some parts were mixed. Some some x quantities from first vessel and y quantities in the second vessel it was taken, and the resultant mixture spirit to water ratio is 1 is to 2 is given. So if this two be happen, how many parts of if I say x liters of from first vessel and y liters from the second vessel, then he's asking to find out x is to y ratio. In the previous problem, initial ratios were given, and this x is to y it is given as same quantity, which is 1 is to 1 ratio is given. This problem, previous problem, we calculated the ratio of spirit and water in the resultant mixture, but now resultant mixture ratio is given, and the quantities in which we need to mix, here he is asking you to calculate. So this problem straight away, the numbers is very easy, guys. This problem, it is given as 1 is to 3, 3 is to 5. Uh, so then what happens is, and the resultant mixture is having 1 is to 2 ratio, spirit and water. So if you clearly observe the first vessel 1 plus 3, 4 liters, and the second vessel 3 plus 5, 8 liters, and if you mix straight away in this thing, so then what happens? The spirit to water, which is 1 plus 3, 4, and the water is 3 plus 5, 8, which is 1 is to 2. This is what I got. It is given. So the resultant mixture should be 1 is to 2. I straight away got the answer that I need to take 4 liters from the first vessel and 8 liters from the second vessel, so that the resultant mixture also will have spirit and water in the ratio 1 is to 2. This is my answer. Sometimes the numbers may not be this easy, I need to give you another way, the actual method, the traditional method, for to solve some other problems. So I need you to understand this problem. I solve this problem. I name this problem method as butterfly method. Okay. So how? So this is what now? So this is a butterfly method. So how? Simple, guys. Just look at the first. In the first vessel, spirit is of how many parts? One part out of total four parts. So I'm going to take spirit. The first vessel, one out of four, and the second vessel spirit is three parts out of eight. This is mixed, and in the resultant mixture, what I need to have spirit one out of three parts. So 1 out of 4 parts, this is nothing but percentages, guys. 1 by 4 into 100, which gives me 25 percentage. 3 by 8 into 100, which is 37.5 percentage. But I'm not going to take percentage values. The reason is decimals are there. It may confuse you. So I'm going with the fractions. Okay, if you multiply with 100, it will be percentage. If you don't multiply with 100, it's a fractions. So what I'm going to do is, I'm going to take this. So I'm going to take a difference of these values and I'm going to take ratio. The resultant ratio which you're going to get is of quantities ratio. Okay, that's it. So this is of 3 by 8 minus 1 by 3 you need to take ratio, and this is 1 by 3, this one. So this difference I need to put here. So 1 by 3 minus 1 by 4. So 1 by 3 minus 1 by 4 is of denominator 12, and 3 times for 12 in 3 times is 4 times. So 4, and for this is numerator will be 3, 4 minus 3, 1. And here it is 24, 8 times 3. So 8 times 3 is, so 3 times 3, 9. 9, and this will be, this will be 8. So 9 minus 1, sorry, 9 minus 8, 1. So I got the ratio 1 is to 2, 1 by 24 is to 1 by 12. So by simplifying it, I'm going to get it as 1 is to 2 ratio. This is the way how you do solution for some other numbers. But this problem numbers are easy. So I straight away got 1 is to 2 answer. But I need you to understand this method. So this is a very important method in allegations. So let's straight away go to our third problem now. Yeah. So uh, this is the thing, guys. A mixture worth 3.25 a kg. So he's given a cost 3.25 kg is formed by mixing two types of flour. This is a resultant mixtures cost 3.25 kg. So 3.25 rupees mixtures, and it is formed by mixing two types of flours. One costing at 3.1 per kg and the other costing at 3.6 kg. The resultant should be sold at 3.25 kg. So simple, guys. The first variety is of 3.10 rupees mixed with 3.60 rupees, and this resultant is selling at 3.25 kg per kg. So if it is to happen, then in what ratio I need to mix? That's it. Again, I'm using my butterfly method. So here what ratio I'm going to get? Quantity ratio. I've taken cost price into account, and I will be getting quantities ratio only. So again, difference 3.25. So the difference of 3.25 and 3.6 will be how much? So 3.6 minus 3.25 is it's 0.35, and the difference of 3.25 and 3.15 3.10 is 0.15. So it is of like I am removing the decimals. It has 35 is to 15, and this will cancel out in 7 table. So 7 5s are 35. Sorry, it will cancel out in 3 table. Sorry, it will cancel out in 5 table, 5 sevens, 5 threes. So this is our ratio, which is 7 is to 3. I hope this, you are understanding this butterfly method. This is a very important method, guys. Please do follow this. And let's go to our fourth problem. Yeah, here this is of like profit loss mixed problem here, guys. It's of a mixture allegations only. So here it is given how many kg of rice worth 30 per kg mixed with 50 kg of another variety costing 60 per kg to sell at 55 per kg, thereby gaining 10% profit. Nice. Simple guys, here there are two varieties of rice is taken at some quantities were mixed, and the resultant mixture is sold at 55% profit. Okay, 55% rupees, and he told he gained a profit 10 percentage. So if you are taking this also should be solved in butterfly method. So remember guys, the in the butterfly method, whatever the quantities you are writing here, all these three quantities should be of same type. Sorry, it should be of same terms only. Like if you're taking cost price here, this also should be cost price, and the resultant one also cost price you need to take into account. But here this 55 rupees is a selling price. Profit he is given as 10%. So calculate cost price. So how to calculate? I know that cost profit he told. So means profit 10% means 1 out of 10. For 10 rupees cost price, I'm getting 1 rupee profit. So selling price is 1 plus 10, 11. So if 11 parts is nothing but given 55 rupees, then I need to calculate cost price which is 10 parts. So 11 parts 55, 1 part 5 rupees. So 10 parts 50 rupees. So I got cost price. So I already told. And what is the ratio I'm going to get here in a butterfly method? Quantities ratio. From this, I'm going to calculate the problem. So what is the initial variety cost price? Initial variety cost price is how much? 30 rupees. And the second variety cost price is how much? 60 rupees. Resultant is selling at cost price what? 50 rupees. So this is what I need to take. So 30 rupees is initial, 60 rupees is sorry, the first variety 30 rupees cost price, second variety 60 rupees cost price. Resultant is of 50 rupees cost price. So I've taken cost price and quantities ratio I'm going to get. Take the difference of 50 and 60, which is 10. Difference of 30 and 50, 20. And the quantities that should be mixed is 1 is to 2 ratio. And he's already given the first variety. I don't know the first variety. How many parts, how many kgs I am mixing the first variety itself he asked. So this x kgs is mixed with how many kgs here? It's given how much? 50 kg. So the second variety is 50 kg. So it's directly x to 50 kg is 1 is to 2 ratio we got, which is x equals to 25 kg. This is my answer. I hope you got it. So remember guys, cost the quantity, the terms should be same. If you're taking cost price into account, so all three should be the same. Let's move on to our fifth problem. So again, this is also similar problem. I hope you just pause this video, try this question by yourself, and you need to get answer. Uh, let's see. How many liters of 60% solution to be mixed with 50 liters of 90% solution to make 75% solution? So that's it. So I forgot to mention here, it's like 60% some acid solution. I call it as hydrochloric acid. Okay, hydrochloric acid solution. Clear? Some acid solution. Okay, now that's it. So it is given first one is of 60% pure and the second variety is of 90% pure and the resultant should have 75% pure. And I told you, so this is nothing but quantities ratio I'm going to get. The difference of between 75 and 90 is 15. The difference of 15% and the difference of 60 and sorry 15 and the difference of 75 and 60 is also 15. That means 15 is to 15, which is 1 is to 1 ratio I need to mix. That means if 1 liter of 60% solution if you take should be mixed with 1 liter of 90% solution. So but here it is given 90% solution if he's taking 50 liters. So if 90% solution is 50 liters, so then I need to take 60% solution is also how much? 50 liters. I hope you got it. This is our answer for this question. Let's move on to our sixth problem. Fine. How many liters of 60% solution to be mixed with 80 liters of 90% solution to make 80% solution? That's it, guys. Again, first type is 60%, second type is 90%, and the resultant should have 80%. So same, take the solve with butterfly method and find out the quantities ratio. 8 and 90 difference how much? 10. 60 and 80 difference is how much? 20. So it should be mixed in 1 is to 2 ratio. And here it's clearly mentioned that the second wear type is taking 80 liters. Okay, and the first type we don't know, let it be x liters. And which is nothing but x to 80 liters is nothing but how much ratio? 1 is to 2. So this is it. So this is nothing but 40 liters. So 40 liters of 60% solution should be mixed with 80 liters of 90% solution to make a 80% solution. That's it. So this is our answer. Let's go and solve our seventh problem now. Fine. This is one type of question where in many exams they are asking frequently. It's of a little lengthy solution, but this solution is a little lengthy just because of the values, guys. The method is same. So here, a jar full of whiskey contains 40% alcohol. A part of this whiskey is replaced by another containing 19% alcohol. Now the percentage of alcohol was found to be 26. The quantity of whiskey replaced is. So here follow the same method, guys. The first jar is containing 40% alcohol. Can I say 40% is nothing but 40 by 100? And it was replaced by some part of it is replaced by 19% alcohol. Can I write it as 19 by 100? And the resultant mixture is having how much? 26% alcohol. So can I write it as 26 by 100? So take differences, guys. This is the initial jar, and this is replaced by 19% alcohol. So what is the difference between 26 and 19? Which is 7 out of 100. And this is uh, 40 and 26 difference is 14 out of 100. And the ratio 7 is to 14, you will be getting 1 is to 2 ratio. That's it. So that means initial a jar should be of one part and the replaced value is two parts. So he is asking the quantity replaced. So simple, guys, the replaced is how much? 2 liters. Let us consider like total is 3 liters. The ratio is 1 is to 2. So the replaced value is 2 out of total how much? 3. So this is what 2/3 part has been replaced. So this is initial one, this is replaced one. So 2 out of total 3 is replaced. Or else I can say that 2 out of 3 into 100, which is 66.66 percentage of initial alcohol is replaced. So this is our answer. Let's move on to our next problem. So yeah, so this is also a problem from mixtures and alligations, guys. A mixture contains milk and water in the ratio of 3 is to 4. If 5 liters of water are added to the mixture, then the ratio becomes 3 is to 5. What is the initial quantity of mixture? So milk to water ratio initially it is given as 3 is to 4, and later some manipulation of water or some water has been added and the ratio became 3 is to 5. Guys, here he's adding only water he's been added, right? Some 5 liters is adding, only water is added. That means only water is added. That means there is no change in milk. That means the ratio or the number remains same. And luckily in our problem, the part of milk is 3 in the first ratio and 3 in the second ratio. That means the milk has not been changed. Only water has been changed. How many units? 1 unit has been changed. That's it. And we know that is nothing but what? How many liters? Like if you see, 1 unit is nothing but only water is added, which is 5 liters. So we straight away got this. So with this, we can calculate whatever the value he asks. It is given what is the initial quantity of mixture. Fine. What is the initial quantity of mixture? 3 is to 4, right? Which is total how many parts? 7 parts. Sorry, 7 units. So 1 unit is 5 liters. Then 7 units will be 7 into 5, 35 liters. Okay. Uh, yeah. Yeah, guys, there was some mistake in the options. The answer is 35 liters. Fine. Let's move on to my next problem. Yeah. Okay. The question is in this way, guys. A mixture of 40 liters of milk and water contains 10% water. How much water must be added to the mixture so that the water may be 20% in the new mixture? So let's see, guys. There is a mixture in a vessel. This is of 40 liters he mentioned. Let it be. And he's telling this is of 10% water is there. And he's telling some pure water is mixing. He's mixing some pure water. His only water is mixing, right? There is no milk, or else I can say that 100% is water only. And by mixing, the resultant mixture should be of some quantity, and the resultant mixture should have 20% water. Correct? So again, I'm going to use my butterfly method here itself. I told you now. Here, 10%. I'm taking water into account. So 10%, and the second vessel also you need to take some water percentage only, which is 100%. Is mixed with mixed, and some new mixture is formed, which will have 20 percentage water. So this is also water. And I told you now, when you are taking applying this particular method, the ratio which I'm going to get will be quantity ratio. Clear? So the difference is 20 to 100 is difference is 80. 20 and 10 difference is 10. So it is of 8 is to 1 ratio. So I know this is the jar which is I'm using 40 liters, and here I'm going to use some x liters. So this 40 to x ratio is what as 8 is to 1. If it is the case, then x equals to what? 5 liters. That's it. That means 40 liters of 10 percentage water. Solution is mixed with 100 percentage of water to make a 20 percentage solution. That's it. The answer for the question is 5 liters. Let's move on to our next problem, guys. Last problem in this set of problems. Fine. A dishonest milkman professes to sell his milk at cost price, but he mixes it with water and thereby gains 50%. The percentage of water in the mixture is, uh, yeah, it's very simple, guys. It is given like, let's say, it is given like he's gaining 50%, right? That means, let's say, for 100 per liters of water, can I say that he's adding he's adding 50 liters of, sorry, 100 liters of milk, 100 liters of milk, he's adding 50 liters of water, so that his cost, he's selling this total quantity for 150 rupees, but this is selling price, but his cost for milk is 100 rupees only. So by mixing this 50 liters of water, he's selling for 150, and he's gaining how much? 50 rupees, which is of, okay, he's gaining how much? 50 rupees. So he's gaining, gain percentage is how much? 50 percentage of cost price. Correct. So that's what gain percentage is. Gain is 50 rupees. So that's it. That means for every 100 liters of water, he is adding 50 liters. Sorry, 100 for every 100 liters of milk, he is adding 50 liters of water. So which means out of 150 liters, how many liters is out of 150 liters of solution? How many liters of water is there? 50 liters. So I need to calculate this percentage, which is nothing but 50 by 150 is 1 out of third, which is 33.33 percentage. That means In this mixture, 33.33 percentage is water. So this is my answer, option C. I hope you got this type of problems. And there were some set of other type of problems which was discussed in my other mixtures videos. Just go through those videos and try to get the complete knowledge on mixtures and alligations. Thank you guys. Thank you for watching the video. We'll meet in other video again.